in question 7 part 1, we are supposed to find this angle XYZ. Okay, so how do we find this? Okay, recall this topic, the main thing is always revolving around trigonometry, trigo ratio, which you make use of right angle triangle. So how are you going to get a right angle triangle that include this angle XYZ? Okay, one thing that you can do is you can draw a perpendicular line down from point X. Okay, and then you will be able to get a right angle triangle. Okay, and in my solution, I actually label this point as L. Okay, to make it clear when you read as to what am I calculating. Okay, so you have a right angle triangle here, and you were told in the question that WK, okay, the length of WK to ZY, alright, is actually 6:13. Okay, ZY is equals to 6:13. So if I make a calculation of WK, okay, 7.8 meters is actually 13 units. So 7.8 divided by 13 times 6. Alright, this will give me 3.6 meters for WK. Okay, 3.6 meters for WK. So if I draw this perpendicular line now XL, okay, this is all perpendicular, so this length XL will also be the same as WK. So this is also 3.6. Alright, so okay, so now we will have sufficient information, okay, to find our angle XYZ. Okay, angle XYZ. Alright, so we have enough info to find this length LY. Okay, this length LY. So we have one side, if we find LY, we'll be able to get use trigo to get the angle XYZ. Okay, so how do we find LY? Okay, we know the whole length here, ZY, is 7.8. Okay, and if we match this line downwards, 4.7 is W to X, so from this point, we drop it down to K, so K to L is 4.7. Alright, so if we are able to find ZK, and then 4.7, we use 7.8, subtract these two lengths, we will get LY, and then we will be able to get the angle XYZ. Alright, so we find ZK here. So how do we find ZK? Okay, we know this is 62 degrees, and we have calculated WK to be 3.6, sorry, 3.6. So we can make use of trigo. This is opposite of 62 degrees. And ZK is adjacent. Okay, so opposite and adjacent, we use tangent. Alright, tangent 62 degrees equals to opposite 3.6 over ZK. So ZK is actually 33.6 divided by tangent 62 degrees. Okay, so ZK can be expressed in this fraction. If you want to leave it, use a calculator, evaluate out the value of ZK, yes, you can do it, but remember, do not round off to 3SF at this point. You have to keep to 5 decimal place to preserve the accuracy eventually, because this is not your answer yet to this part, 7.1. Alright, you're going to use this to calculate more things and then eventually get the answer for this part. Alright, so we calculate LY using 7.8 minus 4.7 minus ZK, which is 3.6 over tangent 62 degrees. Alright, so if you press your calculator, you will get 1.18584 to 5 decimal place. Okay, so now, since we have the length LY here, we make use of LY and 3.6, okay, which is this length XL, we will be able to get our angle XYZ. Okay, so we use tangent because 3.6 is opposite of our angle XYZ. Okay, opposite. And LY is adjacent. Okay, this side XY is hypotenuse, so this have to be adjacent. So adjacent tangent angle XYZ will be equals to 3.6 over Ly, which is 1.18584. Okay, so angle XYZ will be inverse tangent 3.6 divided by 1.18584. Okay, and so in your calculator you should get 71.76803 degrees, and round off to one decimal place because this is angle in degrees, 71.8 degrees to one decimal place. Okay, so this is the answer to 7 part 1. Okay, next, to continue in 7 part 2, alright, we are required to find the perimeter of the entire figure. So this diagram, there are 4 sides to it. We already know the values of 2 sides. Okay, so what we need to do is to find the 2 other unknown sides, which is WZ and XY. Okay, WZ and XY. So in order to find XY, okay, we know that WK is 3.6 meters. Alright, and previously we have found ZK. Okay, we have found this ZK. So, and this is a right angle triangle. We can use Pythagoras theorem to get WZ. So WZ square is equals to WK square plus ZK square. Okay, so to get WZ, we can substitute in the values. 3.6 square plus ZK is 3.6 over tangent 62 degrees whole thing square, and we square root this. Okay, so we work this out in your calculator. You will get WZ being 4.077252 meters. In my PDF solution, I actually use another method to get WZ, which is making use of 62 degrees and 3.6. Okay, so 3.6 is opposite of 62. So you can actually form sine, to find this hypotenuse, you can form sine 62 degrees equals to 3.6 over WZ. Okay, so this is another way. You should get the same answer for WZ, okay, in using Pythagoras theorem as well. Alright, so the next side that we want to find is XY. Okay, so in the previous part, okay, I've already explained. We can drop a line down, right angle triangle. So this side here is 3.6 meters, same as WK, and we have found this point LY. Okay, the length of LY over here in the previous part. LY is 1.18584. Okay, so we use Pythagoras theorem again. So xy square equals to xl square plus ly square. Okay, so we substitute in the values. Xy will be square root of xl, which is 3.6 square, plus 1.18584 square. Okay, to evaluate this in your calculator, you will get 3.79028 meters. Okay, take note for xy, value of xy and wz. Okay, I did not round them off to 3SF or any other things. Okay, I just keep to 5 decimal place because I know that later on I will need this value again for calculation to produce my answer. Alright, so to get my perimeter, okay, I add up all the 4 sides. So 4.7 plus 7.8 plus 3.79028 plus 1.077252. Okay, you will get 20.36753 meters. So round off to 3SF, 20.4 meters. Right, so this is a solution to 7 part